When a coder wants to create their own programming language, it's essentially like a gamer wanting to develop their own video game. It's a thing you mostly think about doing, but never get to actually do, because the task is considered tedious and hard. And it's a shame really, because doing such a project has got to be one of the most fun things I've ever done as a programmer. About 2 years ago, I set off to make an interpreted language without any prior experience. My only goal was to create the most minimal language that allows you to create basic games using it, and in this case, Pong. But looking back, I wasn't that keen on the result. I mean, yes, the language technically did its job, but it didn't feel like a functioning language. It is kind of important to say that I did return to that project after a while and rebuild the entire thing from the ground up, but other than some new quality of life features, nothing really changed. The thing that bothered me most was the fact that there was no way to write nested expressions. For example, if you wanted to write a program in C that creates a variable called b that contains the value of a plus 5, you would just write something simple as that. In Glang, the language I made, you would be forced to do one of the two. And that is just one example of how important nested expressions are to the usability of the language. So now, more than a year later, and with my programming skills improved, I thought it was about time I retry this project and make something different. Now, parsing languages like assembly or Glang is fairly simple. Each line contains only one command followed by its arguments, so it's really clear to the program what's what. This obviously isn't the case when you add nested expressions to the mix. What most tree languages like Python have is a part of the parser called a lexer. The lexer takes the raw text of the code file and breaks it down into a tree of actions called an AST. This is good and all, but it's super hard to implement, so I looked for another solution. After a bit of thinking, I reached a nice middle ground idea. Everything in the language is going to be a node. A node can be a simple value such as an i32, or it can even contain other nodes. This can work infinitely, and while it doesn't look the best, it's really flexible and easy to work with. With a theory in mind, I set off to build the most important part of the puzzle, taking a line of text and converting that into a runnable node tree. Hello, so let me show you a bit of what I've been working on up until now. So, as you can see, there are nested operations within operations in this language. So you can do a set name and the value will be the value of cal, which is short for calculate, and var plus 6. So in order to do that, you need to actually do a bit of a node tree. So everything within a square bracket is considered a node, and if there are nested nodes, I mean a node within a node, then you need to do almost like a branch of the original node. So it will be much easier to see visually. So I did a bit of code that I will sort that out for this line specifically this time. And let me run it really quick. Run. As you can see, here are our detected lines from the file. And as you can see, there is the root node, which is of course nested because there are multiple nodes in this line. Then there is a command which is just the value name, and the second node, which is a nested one, which has the value of the command and 3 child nodes of its own. So as you can see, it did translate that correctly. While I was able to parse lines into nodes, having them laying around the program was no good. So after a bit of work, I introduced the concept of scopes. Every program written in Neve, which is the name I chose for this new language, is going to be divided into root scopes. These scopes can hold a list of nodes or even subscopes. With this new technology, I was able to add the if and while commands. And for the first time, you can mark the start and the end of a scope using curly brackets. Unlike Glang, which as some people here may remember had a suboptimal solution to this problem, to say the least. Next came graphics. I wanted to add a tiny graphics API to Niv, mainly because I wanted to create games using it. To achieve that, I tried to import a graphics framework I wrote for a game I made a while ago, but after trying again and again, it just wasn't fit for the job, and gave nothing other than errors. So I resorted to making a new one specifically for this project using SFML, a task that was surprisingly easy to do. And after overcoming that issue, adding the graphical API to the language was a really straightforward process. Using all the things I made up until this point, I was able to write fairly complex programs, starting from a moving pixel all the way to a controllable player. Being able to handle these programs can be considered a hard goal to achieve, but it's nothing that I haven't done in the past using Lang. No. The real thing that I wanted this language to do was to be able to run itself, and after writing a fairly small script, a Niv command line interface was possible thanks to the node system. It's pretty safe to say that after achieving a goal such as running your language within itself, you should be pretty happy with how it came out and probably leave it there. And that is what I initially wanted to do. But after looking through the code for cleaning purposes, I realized how much unimplemented potential this language had for no reason. For starters, remember the root scopes I told you about at the start of the video? Well, I did implement them, but never made anything that actually benefits them. So after changing the parsing code a little, root scopes became the Niv equivalent to functions. And it goes without saying that it made Niv 10 times more practical to use. Adding functions with such ease made me think about how Niv could get so much better, and sent me on a rampage of adding new features in an attempt to develop this language to its full potential. I started by adding the option to have multi-file programs. The idea behind that is that if I already have functions within my language, I might as well allow users to write Niv libraries using Niv. Following this line of thought, I figured that having libraries with only functions isn't really practical, and the fact that users cannot define their own types is very limiting. So, to solve these issues, I added a new feature called userType. They are basically Nivs equivalent to structs, and allow you to define your own data type by defining your type's name and its fields. You can even choose between a default and a custom constructor when creating a new object. Seeing how easy fitting user types into the type system was, I added lists, which are basically like Python lists, being an array of any type with a varying length. I also added a way to treat strings as an array of chars in order to make them a bit more useful, and also a simple file read and write API. Using all of these newfound features, I was able to make things that were ridiculously hard to do or outright impossible in my previous languages, such as a Flappy Bird clone or a full-on brainfuck interpreter. And that is just the tip of the iceberg, because Niv isn't limited to specific examples like its older alternatives, and that, in my opinion at least, makes it a real programming language. It's alive! It was after adding all of these features that I finally noticed something really subtle about my language once again. Niv looked ugly as f***. The problem was with how the language was parsed. The syntax was designed in a way that will make parsing it the easiest it can possibly be. And while the language visually made a lot of sense for the computer, a human could hardly tell what's going on. It's also needless to say that physically typing commands in such a format is nothing but pain and irritation. It was clear that Niv can't be shipped with such a bad programming experience, so things had to change. So after hitting my head against the wall for a couple of hours, I introduced a new set of rules to the parser. The basic idea is that if something doesn't need to be inside the node declaration, it shouldn't be. This means that lines like this will transform into a much cleaner format. And this one change, without any single doubt, was the most important thing I've ever done to this language. Just look at the results. Looking back, I can definitely say that I had a lot of fun working on this project, and I'm definitely looking forward to continue developing it. While working on this project, I had to change my coding style entirely to fit one that matches language development as opposed to my usual game development style. And that was a surprisingly unique experience that I highly recommend for anyone interested in a new and refreshing project. But with that said, the project is open sourced on GitHub, so as usual, you're more than welcome to check out Niv and even look through the code if you feel like it. And other than that, see you next time.